Hello, hello. Thanks for coming. Just a small little project we've been working on over the last year or so. Welcome to Signal Forms. Yeah. So we've noticed Angular developers tend to love our modern reactivity system, right? Signals bring a simplicity and a breath of fresh air to state updates. No mark for check, no expression change after checked. Whether your application is using zones or not, server or client, signals just work. And even better, they compose really well. Computed makes doing derived states very easy. Link signal handles more complex scenarios. Now we have the experimental resource API that does asynchronous derived state. But also, forms and signals are, in fact, a perfect match. The use case of forms was pretty central, actually, to the design of Angular's signal system and our validation of those APIs. We saw forms as an exercise in complex state management. And if you couldn't do forms well on a signal system, it probably wasn't a very good signal system. So early on in our reactivity exploration, we knew signals would be the ultimate test of Angular reactivity. And even before we released signals, we knew at some point we would have to deeply integrate them into the form system. So last year at NG Poland, Pavel and myself announced we were getting started with that.
Yeah, and so we knew we were about to invest a whole bunch in bringing signals and forms together, but of course we saw that as an opportunity to address the situation with forms more holistically. We were probably aware we've got the two kind of separate form system. We got template-driven forms and also reactive forms. And they each have kind of their own unique strengths, right? So template-driven forms is it's great for simplicity, right? It's like very easy to set up. It gives you kind of a nice declarative way to add validation and stuff. And then reactive forms is great for these like robust, forms with more complicated logic and that sort of thing. And so we really want to take like the best of both of those, combine it along with the power of signals, and give us kind of like the ultimate form system, the one form system to rule them all. So, yeah. So given that kind of lofty ambition, we set out to design signal forms, and we had a couple of design goals in mind when we started this out. And the first kind of important design goal we saw is that we wanted to make sure we made a form system that scales well. And so this I mean like something that works great for any size form you might want to make, whether it just be like some simple data entry or some like, super complex multi-page stepper form where you got to go through this complicated workflow, right? And we want signal forms to be something where it's very easy to get started. You don't need to learn this whole giant API, but you can easily accomplish your task that you want to do. But as you get to these more complex use cases, you're able to slowly add on, more and more pieces, and it gives you the tools you need to be able to manage the complexity of your bigger forms.
Yeah, so the next goal we want to make keeping the form in sync with your application's data model pretty effortless. This has been one of the biggest pain points of forms in Angular, particularly around reactive forms. When the shape of the data changes, like you're adding new items to an array, updating the form model is often a challenge, right? And having an add row button in your UI should not require a whole ceremony to get working.
Yeah, and another goal we had, of course, is to take full advantage of the power of signals for reactivity. And so we want to go beyond just the basics of course, we need to give you the value and the errors and all of that as signals. That's important. We're going to do that. But we can do so much more than that, because if you think about some of the problems that you run into in forms, like I want this field to be disabled under certain conditions, or maybe the validation of my one field depends on the validation of another field. These things kind of sound like a perfect fit for computeds, right? And so we want to be able to build those directly in. And furthermore, even if I have some like reactive state outside my form, maybe in like a service or something, right? I should be able to pull that in as well and kind of derive my form state from that. And so that's what we mean by like really leveraging reactivity to define your form state.
Yeah. So fourth, right, forms don't exist in a vacuum, and we're not creating signal forms from scratch. There's a whole ecosystem of validation utilities out there. Things like Zod or Valabot or Vest.js. And signal forms does not need to reinvent the wheel in terms of data validation. You should be able to bring your own tools and use them when it makes sense.
Yeah. And another thing that we thought was really important is this ability to compose together smaller pieces. And so this is something that we feel like people have kind of struggled with a bit in both reactive forms and template-driven forms. But we want to be able to, split our form into smaller pieces that are independently testable, reusable, and avoid needing to have that, 5,000-line God form type of thing. And so yeah, that fits really well with like, the natural composability of signals themselves.
That sounds pretty great and hard. We've been working on it. But this is Angular, right? An amazing form system isn't enough if you have to rewrite your existing forms to use it. Backwards compatibility is our DNA. So whatever we build has to fit within the existing forms ecosystem, has to be able to interoperate with components that people have already written. Or you have to be able to start using it within your applications today, even if you're on reactive forms. So we may have some examples of this later, talk about how we're getting into it. But before we dive in, I want to give you a quick disclaimer. There are code examples in this presentation. We're going to show you how things work. And all of the examples do work in the -next release that you can go and try out. But signal forms are experimental, and we really actually mean it. The API is not finished, right? It's not stable. We have 2 designations for such APIs, where we talk about developer preview. That's kind of like a release candidate. Those are things which are finished. We think they're feature complete. We think they're what's needed. But we want to give it some time to circulate around the community and see if you can find problems. Experimental is not that. Experimental APIs are truly unstable. They might be missing features. They might have known issues. We release them because we think it's valuable to have feedback earlier in the design process. And this is the case for signal forms. So it's very possible some of these things might change by the time you get them in your application.
Yeah. And so with that disclaimer out of the way, let's go and take our first look at some signal forms code. And I forgot how to use this clicker. There we go. And so first, starting over on like the TypeScript side, we have a simple component here to display a feedback form to the user. And so we just want to collect some simple information like their name, email, and the feedback that they want to give us. And so to do this, we create a form using this form function that we've imported from Signal Forms. And we kind of pass it the signal with the information we want to collect. And then we've also got this new control directive, which is also part of Signal Forms, that we're going to go import so we can use that in our template. And so then moving over to our template, we can see how we use this directive. We just go ahead and place the control directive on the native controls that we want to hook our form up to. And we hook up the individual fields on our form so that the user can enter the information, and we'll have the nice two-way binding. And we can start to see from this small example some of the important properties of signal forms. So first, kind of most importantly, it is signal-based, as the name would imply. And so what we pass into the form function is a signal. And not just a signal, it's actually a writable signal. That's because the signal forms doesn't make a copy of this data. It actually operates directly on the model that you give it. Right? So you pass in your data model, and then as the user edits an input or something, it will directly update the model that you passed in. And so this helps eliminate these kind of like synchronization errors where, forms has a copy of the data, you have a copy of the data, and you gotta try to keep them in sync all the time, right? That's not a problem here because the form directly updates your model. And then it's also model-driven, and what we mean by this is that the structure of the data model that you pass in determines the structure of the form that you get out of this thing. And so, like flipping back over to the template, we can see that the properties available on the form, this like name, email, and feedback, are the same ones that were on the model that I passed into it. And so we kind of automatically reflect the properties that are on your model on the form. And so maybe you're wondering, like, what is this thing that the form is returning? Well, it returns this thing we call a field. And a field is kind of a tree structure that contains all of your state of your form. And in order to get to a subfield, we can just use this dot access, and that'll give us a child field. And then we can also call a field like a function, and that gives us access to all of its state. And so its state is basically a collection of signals that tells you things like what's its value, is it valid, errors, disabled, all these other things that you might want to know about that field's particular state.
Yeah, I love how straightforward it is to get started, right? It's just a couple lines of code, form and signal to create this wrapper, and you're off getting started. But of course, forms are more than just being able to edit data. We also have logic, right? We have business logic associated with them. How do we validate the data that the users entered, or enforce that things are required or should be disabled, and so forth? So let's look at an example of that. Here we have a contact form. So we're going to collect email and phone number, both two data types that need particular validation associated with them. So again, we see a bit of the simplicity, right? We start with a model, and then we define a form based on that model. And forms will go ahead and edit the signal when things change. So the first thing we're going to do to add our validation is pass a second argument to this form function. And we call this a schema, right? And this is a callback function that's going to get called when the form is created, and we can declare logic that should be applied to different fields within this schema. And that contact argument is a reference to the path of the field that we're going to add our logic to. You'll see how that works in a second. So for example, we want to make the email address required, right? The user has to enter it. And to do that, we import the required logic helper. Signal Forms has this DSL built in of all of the various kind of logic declarations you can add inside of a schema. And we specify here the error message, what should be shown to the user if the email isn't there. Another logic helper you can use is the email function. And if you're familiar with existing forms, you'll recognize these. These are some of the same validators that are available in the other form system. Here we're also adding it to the email field. And you can also define your own validators, right? You're not limited to the built-in set. So the validate function is how you add completely custom validation logic. For example, in this case, we're disallowing government emails, emails that end in .gov. And notice here the validate function is receiving arguments, and we're using the structuring to grab the value argument. This is the value signal of the email that we can then factor our validation on. And so you might recognize here we're actually defining a computed, right? We're defining how to derive, given the value of the signal, what the validation state should be, what error message should be shown. And we're not limited to just reading the value signal. Like if you want to go and read whatever other signal or state and services you have, go for it. Similarly, for phone number, we can use min length, max length to set some expectations around the phone number. We could also add patterns around, try to do some regex thing to validate that it looks somewhat like a phone number. And one of the nice things about this API is when you get to the template, the required attribute on the email address and the min and max attributes on the phone number input will be automatically added by Signal Forms based on the metadata that you've described here. So we know the field is required. It'll show the little star. It'll tell HTML that it's required. Same goes for min length and max length.
Yeah, and so thanks, Alex, for that awesome introduction to the logic. And it's really cool, but sometimes we need some even more kind of complex logic where maybe the validation state of one of our fields depends on, what is the value of a different field. And so how can we do something like that? So that's what we call cross-field logic. And so let me see. Yeah, so a common scenario where we might run into something like this is a sign-up form where we want to collect the username and then password, but then just to make sure that people don't forget the password, we want to make them type the confirm password. We want to make sure that those password and confirm password match. So again, we can go set up our schema, taking in our sign-up form. And then in order to do this cross-field validation, I do a validate function like Alex just showed. And now he showed how you can get the value of the current field in your validation function that runs here. So you can actually destructure some other things out of this field context as well. And one of them is a function called value of. And value of lets us read the value of any other field in our form. So in this case, using the value and the value of is very simple to just say, make sure that they're the same. If they're not, then we want to show an error message, and otherwise, everything's good.
How many people have built that exact form? Yeah, quite a few.
Yeah, and it was difficult, I assume. And so another thing I mentioned earlier is wanting a good composition story and being able to break your forms down into smaller pieces and use those to bring together and build a bigger form. So how can we do this in signal forms? Well, let's use an address book form as kind of our example for this. And so we'll say that we want to take in my own contact information, as well as I have a list of friends or something that I want to put their contact information in. And now, regardless of whose information I'm collecting, mine or theirs, it's going to be the same basic set of things. It's going to be like the first name, last name, email. And so I'll just abstract that into a separate model. We'll call it contact model. And then for convenience, I'm also just going to add a quick empty contact, which will be useful in a second. And so then using those types, I can then go define the data model for my signal form. And so I create my address book model, and I'm just going to spread in that empty contact that I created for convenience. And we'll start off the contact list as just empty, and we'll, the user can add some of their contacts in the form. And then for validation, we're going to probably want to, do some checking on this data. For one, let's make sure that we have actual contacts. Otherwise, what's the point of a contact book, right? So we'll go and add them in length to that. But now I probably want to go a little bit further, right? Like I want to make sure that those emails in my information, as well as my contacts information, those are properly formatted emails, for example. And so how can I do this in a kind of reusable, composable way? Just like we can specify the schema, inline when we're creating the form, we can also create these kind of standalone ones using the schema function. And so over with my contact, I can kind of create a base schema that should apply to any contact I create. And so I'll do that. I'll say like, you got to give me your first name and your email's got to be correct, right? And we're going to want to use this for any contacts we might have in our address book. So then coming back to our address book, we can then import that schema that we just created. And for myself, I can use the apply function here to take that schema and apply it to the subfield, specifically the one that has my information. And so now we'll have all of that standard validation for a contact there. And I can also use apply each, which is going to take that schema and apply it to every element of my contact array. And so then I'll have the validation all for everybody and be able to reuse that same little chunk. And so then we're almost ready to create our address book template, but the point of this was composition, right? So we need to make our contact entry, which will just be like kind of a little subform that collects the information for just a single contact. And so for that, we'll go ahead and use this mat form field because we want it to look pretty with mat input. And I'll hook that up to my control, which I'll take as an input. That way it would allow me to pass in either myself or one of my contacts that we want to edit. And that all seems cool. There's just one problem. Does Angular Material actually support signal forms yet? Well, actually, it turns out it just came out, and it doesn't. But that's OK, because Signal Forms has built-in interop for anything that uses control value accessor. So mat input, which uses control value accessor, can kind of already talk to Signal Forms, even though Angular Material hasn't had a chance to update to it yet, which is really cool. So now, moving back to the address book, we can finally go and create our template. And we can go add a contact entry component that I just made, pass in the subform for my own information. And then I can just do an @for over my contacts and do the same thing, add one of this contact entry component. And so it all composes together nicely, and we're able to reuse that single piece. But then, of course, my contacts are actually empty because that's how I set up the form, and we're going to need the user to add some contacts. So I'll add a button that lets people do that. And then we'll have to go add the logic for that as well. And we can see that this is actually really easy to do in signal forms because the form gives you access to a writable signal of the subfields. And so even though I only passed in a signal of the entire model initially, of the entire address book, Forms is able to kind of tell the structure there, and it's able to give me this writable signal to just the value, where I can simply push in a new contact, and that's all I need to do to add to my list. And because I used the apply each earlier when I was applying the schema, this new contact is going to pop in like automatically with the validation and everything it's supposed to have, because that applies to any contacts in the list, even ones that are added later.
So earlier, right, Katerina was surveying like, what's your favorite Angular API or thing you're most excited about? I was surprised no one said control value accessor. Right? I thought that was everyone's favorite API. Yeah, the composition model is my kind of second favorite part of signal forms. This is probably my first. How easy it is to build a custom form control. So remember, a custom form control is a component that gives you the UI to edit a particular type of data. Think like a date picker or a rating control. For example, like this star rater, right? So the user can select from 1 to 5 how many stars they want to give this talk, for example. Pick 5. So let's build this component, right? And I always kind of start thinking about when I want to build a component, what I want the user experience to be, what the public API of the component is. So let's do this for our rating component, ignoring forms entirely, right? What should it just look like as a plain Angular component? So I'd probably want an API of something like this, where the developer can say, oh, I have a rating, I'm going to store it in a signal. I can set that and update it as I need to, depending on what my backend says. And then I'm going to two-way bind that rating into my component using this value binding. And that way, when the user changes things, it syncs back to my signal. And when I need to update the rating, I can go and do that, and it updates the UI. Two-way binding is awesome like that. So let's scaffold it out, right? We have a component, we'll have its template, and we'll take in the value as a model input. Remember, model is sugar for a two-way bindable input. Then we can use some array trickery inside of a computed to create our list of stars to render. This just figures out whether we should be showing which material icon we should be showing for each star, and then iterate over that in the template inside of a for loop to show those icons. Next, we'll want to handle user input. So when a star is clicked, we set the value of the model signal, which both updates our UI and notifies the two-way binding if there is one that the parent needs to change, that an update was made. And for good measure, let's add a disabled input. So maybe I want to show this control, but don't want to actually let the user edit it at a point in time. This lets you display the current value, but we'll turn off pointer events and we'll dim the UI out. So we end up with this API that we wanted, right? So our next step is to add support for signal forms here. Actually, it already works. That's all you need to do. Yeah. as written, this component is compatible with signal forms. We don't need a control value accessor. We didn't even need to import anything from the form system. And it works because of these lines. The secret is that value model input. So when signal forms control directive sees a component that has a model input named value, it says, oh, I know how to work with this. It's a form control. I can two-way bind that to the value inside the form. And if the component has a disabled input, it says, oh, I'll tell you whether forms thinks this thing should be disabled. The same goes for required, min, max, errors, many other properties that are on your form state will sync automatically to a component that has those corresponding inputs, all type checked as well. So signal forms is a work in progress. Many parts of this puzzle are missing or incomplete. Still, we're really excited about the potential here. We think we've built something that's actually quite interesting, and we're really looking forward to getting your feedback on it. So please give them a try, install Angular v21 next, play with it, let us know. I've seen a few people who are very active now on the GitHub issue tracker telling us about all the things we've gotten wrong or have yet to get right. I'll leave you with one final quote that I found, and someone wrote a blog article about signal forms and their first impressions. It's always nice when someone says, nice things about what you're doing, but it's really exciting to see we put a lot of effort into making signal forms simple, powerful, and refreshing to use, and it's nice to see that coming across in the first impressions people are getting while they're playing with it. So thank you very much, and we'll turn it back over to the organizers.